Now, what are the characteristics of nucleus? First characteristic is nucleus size. We already know that the shape of the nucleus is assumed to be spherical. The radius of this nucleus is given by the relation r is equal to r naught a to the power of 1 by 3, where r naught is called radius constant. R is a radius. R naught is a radius constant. Its value is 1.3 into 10 to the power of minus 15 meter, that is Fermi. A is the atomic mass. Now coming to second characteristics, that is nuclear charge. Nuclear charge is the nucleus is positive charged, because we already know that inside the nucleus protons and neutrons are present, but we know that protons are positively charged, neutrons are electrically neutral, hence the nucleus is a positive charge. The charge on the nucleus of an atom is of atomic number Z is given by Q is equal to Z into E. Q is the charge on the nucleus, Z is the atomic number, E is the charge of an electron, that is 1.6 into 10 to the power of minus 19 coulomb. This is about the nuclear charge. Then coming to third characteristics, that is nuclear mass. Nuclear mass means it is a sum of the masses of nucleons. Nucleons means protons plus neutrons. Both the mass is known as nuclear mass. Therefore, nuclear mass is equal to ZMP. Z means atomic number, MP means mass of the proton. This is related to proton mass plus neutron mass. Neutron number A minus Z. A minus Z means neutron number. Mn means mass of the neutron. Okay. Here Z is the number of the protons. MP is the rest mass of a proton. A is the atomic mass number, A minus Z is the number of the neutrons, Mn is the rest mass of neutrons. This is about the nuclear mass. Now coming to nuclear density. We already know that density means mass by volume. Nuclear density means nuclear mass to the nuclear volume. Okay. Now coming to the concept nuclear force. What is nuclear force? Nuclear force is the force that holds the nucleons together within a nucleus. Means within a nucleus both protons and neutrons are present. Proton ಮತ್ತು neutron a nucleus ಒಳಗಡೆ bind ಆಗಿರಬೇಕಂದ್ರೆ we want some force. That force is known as nuclear force. If the force is more, stability is also more. Means we cannot break easily. The nucleus we cannot break easily. These forces are responsible for the stability of the nucleus. These are the characteristics of nuclear. Okay, this is about the nuclear force. Then coming to characteristics of nuclear forces. Okay, first character is nuclear force are the strongest force in nature. We know that from the first year. If the forces are short range are the strongest. The range of the nuclear force is 10 to the power of minus 15 meter. Means very short. Short range means force is strong. Now these forces also short range about 10 to the power of minus 14, which is at a distance 10 to the power of minus 14 meter, and it becomes 0 beyond this. Okay. Now charge independent. These forces are charge independent, does not depend on the charge, because the force between proton and proton is same as the force between neutron and neutron is same, and the proton and the neutron is same. Okay, both those forces are same, hence the nuclear force does not depend on the charge, and these forces are strongly attractive. Okay, it has both attractive as well as repulsive force. It is attractive when the range is greater than 0.5 Fermi. It is repulsive force when the range is less than 0.5 Fermi. This repulsive force prevents the nucleus from collapsing. Means the nucleus collapse ಆಗದಂಗೆ ಅದನ್ನ prevent ಮಾಡೋದು ಯಾವ force ಅಂದರೆ repulsive force. Now coming to next characteristics of nuclear forces are these forces are spin independent. These are charge independent, spin dependent. Okay, ಇವು ಸ್ಪಿನ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ. ಸ್ಪಿನ್ the arrangement of electrons, that is parallel spins and anti-parallel spins. If the nuclear force between the nucleons is having the parallel spin is stronger, and the force between the two nucleons having the anti-parallel spin is weaker. Okay. Now they are non-central. Okay, non-central means there does not act along the line joining the two centers of the nucleons. Means ಇವು ಸೆಂಟರ್ ಇಲ್ಲಿ ಆಕ್ಟ್ ಮಾಡಲ್ಲ, ಈ ಥರ ಸೆಂಟ್ರಲ್ಲಿ ಆ್ಯಕ್ಚುಲಿ ಆ್ಯಕ್ಟ್ ಮಾಡಲ್ಲ, ಹಾಗಾಗಿ ಇವು ದೇ ಆರ್ ನಾನ್ ಸೆಂಟ್ರಲ್. they are saturated. Saturated means each nucleon means it may be protons or neutrons. These exert a force only on its nearest neighbors only. It exerts only near surrounding the neighbor jothe matra exert agadrinda these are the saturated. Their exchange force force means protons and neutrons, they are interconvertible. Means they are proton yavaglu proton agi iralla, neutron yavaglu neutron. They are interconvertible. ಒಂದಕ್ಕೊಂದು ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಹೆಂಗೆ ಅಂದರೆ by exchanging the some particles called pi mesons. Like for example, conversion of neutron into proton. Okay, here neutron is there. Neutron does not remains as a neutron. Neutron agiralla. It will be converted into protons plus electron, and also along with the emission of some particles like antineutrino. ಅಂದರೆ ನ್ಯೂಟ್ರಾನು ನೀವು ಪ್ರೋಟಾನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆದಾಗ ಇದು ಎಲೆಕ್ಟ್ರಾನ್ನ ಎಮಿಟ್ ಮಾಡಿ ಅದ್ರ ಜೊತೆ ಸಮ್ ಪಾರ್ಟಿಕಲ್ಸ್ನ ಎಮಿಟ್ ಮಾಡುತ್ತೆ. ದೋಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಂಟಿನ್ಯೂಟ್ರಿನೋ. Next, conversion of proton into neutron. Again, the proton does not remains as a proton agiralla. It will converted into again neutron. Okay. Next, positron. We know that the electron having the positive charge, it is called as positron, along with the emission of neutrino. Okay, proton neutron convert adaga electron emit madutte and also neutrino particles emit madutte. Now, atomic mass unit, you already know in the chemistry, the first year, atomic mass unit. One atomic mass unit is equal to 1/12 the mass of one atom of carbon-12 isotope. Okay, 1/12 in a mass of one carbon of isotope in a. Now, express in one atomic mass unit in 1 kg. Now, we already know that 1 m is equal to 1/12 mass of one atom of carbon-12 isotope. Okay, this is from our definition. Now, 12 kg of carbon-12 isotope. Suppose we are considered the atomic mass number is 12. If 12 kg of carbon-12 isotope has Avogadro number of carbon-12 atoms. We already familiar with the Avogadro number of atoms. Any amount of substance which having the Avogadro number of atoms. Okay, the 12 kg of carbon-12 isotopes has Avogadro number of carbon-12 isotopes. We want mass of one carbon-12 isotope. Okay, ಇಲ್ಲಿ ನಮಗೆ ಒಂದು mass of one atom of carbon-12 isotope ಬೇಕಾದರೆ ಇದನ್ನು ಇಲ್ಲಿ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ 12 divided by 6.023 into 10 to the power of 26. Its value is 1.99236 into 10 to the power of minus 26. Therefore, the mass of one atom of carbon-12 isotope value is 1.99236 into 10 to the power of minus 26. Substitute these mass of one atom of carbon-12 isotopes in the equation. Okay, we are getting one atomic mass is equal to 1/12th mass of one atom of isotopes is 1.992362 into 10 to the power of minus 26. Finally, we are getting one atomic mass unit is equal to 0.166032 into 10 to the power of minus 26. Finally, we are getting minus 26 is there, 1 point is shifting. Okay, 1.66 into 10 to the power of minus 27 kg. Therefore, one atomic mass unit is equal to 1.66 into 10 to the power of minus 27 kg. Now, coming to Einstein's mass energy relation. In 1905, Einstein established a theory called theory of relativity. He got the Nobel Prize for it. What is theory of relativity? It tells that mass and energy, they are interconvertible. Means we can convert the mass into energy and energy into mass. Now, we know that Einstein mass energy relation is E is equal to mc square, where E is called equivalent energy, m is the mass, c is the velocity of light in vacuum. Okay, how can we convert the mass into energy and energy into mass? Okay, we can convert the mass into energy. This process is known as annihilation. Okay, here one electron is there, one positron. Positron means positively charged electron. Okay, the masses of these electron and positron can be converted into radiations, that is hν. The energy is gamma ray photons are emitted. Those are called energy, radiations. Okay, here the masses are converted into radiations or energy, and the conversion of energy into mass, this process is known as pair production. We are the energy radiations h nu can be split up into positron and the electron, hence the energy is converted into masses. Now show that 1 atomic mass unit is equal to 931 mega electron volt. Okay, this is one problematic. That is, we know that from Einstein's mass energy relation is equal to mc square. M is 1 atomic mass unit. From the last we already know that 1 atomic mass unit is equal to 1.6605 into 10 to the power of minus 27 kg. C means velocity of light, that is approximately 2.99797 into 10 to the power of 8 meter per second. Okay, now substitute these values in the equation 1. We are getting E is equal to M means 1.6605 into 10 to the power of minus 27 into C square means what is the C? 2.9979 into 8 into 10 square. Okay, after we are getting the multiply, after we are getting 14.92 into 10 to the power of minus 11 joule, we have to convert it into electron volt, that is divided by charge of an electron, 1.602 into 10 to the power of minus 19 electron. Its value is 931.5 into 10 to the power of 6 electron volt. 10 to the power of 6 means mega. Therefore, 931.5 mega electron volt.